This is a continuation of my series on electromagnetism. In this video, I will be looking at electromagnetic induction and Lenz's law. You can find this topic in my course entitled Electrical Three-Phase Power Transformer Fundamentals. You can access this and my other courses in my stand store at this web address. Anker has just released a peek at their most advanced multi-device fast charging lineup. In order to check out this advanced lineup, simply go to this web address.
Let's close the loop now, and we'll do that using a resistor in order to limit the amount of current that will be flowing. Because of Faraday's law, a voltage will be induced in the coil, and since we have closed the loop of the circuit, the coil current will flow through that resistor. This brings us to another significant law of electromagnetic induction called Lenz's law. Lenz's law goes along with Faraday's law in that it states when an EMF is generated by a change of magnetic flux, according to Faraday's law, the polarity of the induced EMF is such that it produces a current whose magnetic field opposes the change which produces it. Let's read that again and follow it step by step. An EMF is generated by a change of magnetic flux. That would be induced in the voltage drop across the resistor R. And according to Lenz's law, the induced current will produce a magnetic field. Remember now that anytime current flows, there's a proportional amount of magnetic field induced. And that opposes the change which produces it, as indicated by the green dashed line. In other words, the induced magnetic field is always opposite to the magnetic flux which produced it. This is the reason for the negative sign in the Faraday's law equation. So, in order to check this out, we will apply the right-hand rule. The fingers must point in the direction of the magnetic field, right to left. The thumb will point in the direction of the current, which is up and over, which flows through the resistor, indicating the polarity of the voltage drop as it flows through the resistors, or the resistor. This is all happening for one direction of the permanent magnet movement, which is a net increasing of magnetic flux. When the permanent magnet stops, the voltage will go to zero. And when it moves in the other direction, the magnetic lines of flux linking the coil is decreasing, causing a reversal of the flow of current as well as the polarity of the voltage drop across the resistor. Faraday's law and Lenz's law are very important when analyzing a transformer, as you will see in the next series of slides.
This video is part of my Electrical Technical Information series. Be sure and stay tuned, as I will also from time to time be reviewing electrical products that, in my opinion, are worthy of paying attention to. This address will give you access to the supplier of aforementioned products and is also the connection to obtain a free copy of my 50-page electrical power crib sheets.